Hi everybody, my name is Charlie Kepler. I'm an applications engineer and lead pilot here at Headwall Photonics, and today we're going to walk you through the steps of doing your orthorectification. So the first thing we're going to do is launch our Spectral View software. In a previous video we went through the conversion to reflectance, generating our SBET and generating an elevation model to use. And so now for the orthorectification we're going to do a batch orthorectification batch. We're going to load in all the files from our flight. Select all the header files that have already been converted to reflectance. Once they've all loaded in, looks like we have 26 files. Say next. We automatically find the SBET SBET file in our directory, and then it looks in our C Headwall DEM folder to find an elevation model, but I'm going to manually select the DEM from this specific flight. Okay, looks like it loaded in. The first thing I notice is that my EFL, roll, pitch, and yaw values are automatically populated. Those are pulled from the Ortho-INI file, which is saved in your C Headwall sensor config folder. So we'll go C Headwall sensor config, and then this one is NHP 518. And then it's this Ortho-INI file. These are the defaults that we came up with for this system during our acceptance test at Headwall. And so for the purpose of this demonstration, I'm going to zero those out to begin with, just to show you what it looks like as the defaults. And the default would have been 12. I always select this save Ortho-INI to each local folder. That will update the Ortho-INI file in the directory of the flight with any changes that you make. And so now we can say next, next, and start. This will take a minute or two. Okay, once that has finished, we're going to go to corrections, multi-ortho, and then we're going to load in those files that we just created. They end in IGM for image geometry model. We say next, and we're going to, for now, clear off all the wavelengths and just select the RGB so that it's faster. And then we say next. Let's expand this window. And now we can see we have 1, 2, 3, 4, 5, 6 flight lines, and then a couple over here for our tarp. And we want to exclude the ones with the tarp. So if I hover over, I see that that is raw 0 and raw 19549. So I'm going to remove those from here, which they should be the first and the last. So remove, remove, reset my wavelengths, and then click ortho, and I can give it a unique name if I want, so multi-OR underscore all zeros or something like that. And I can say create. Once that has finished and hit 100%, we can then open it to view it. Again, we only selected 3 wavelengths, so we have just the RGB values there. Open that up, expand the window a little bit. And here's our parking lot. And so if I zoom in, I clearly see that we have a pitch type error here because this is the same thing twice. And if I look here, I see a roll type error here where this is the same thing side to side. Pitch errors can come across as either pitch or yaw. And then similarly with roll errors side to side can either be roll or EFL or magnification. And so the correct way to go about processing this is to adjust for pitch and then look at one of the overlap regions. So we would adjust for here and then look at over here. If we can get this area to line up, but this area does not, then that means we have a yaw correction needed. Similarly with roll, if we can get this to line up, but this to not line up, then we have a magnification error. And I can tell we definitely will have a magnification error because the difference between these two things, which are the same, and these two things, which are the same, are not equal. So if I get this to line up, that still won't line up. So we're going to now go back to the drawing board, go back to our orthorectification batch. For this, we said we wanted to get rid of the first and the last cube. And also to make it faster, we only want to look at 3 flight lines to begin with so that we can see those 2 different overlapping regions. So we'll keep the first 3 flight lines and get rid of the last 3 for now. I can look at the flight lines by the last 3 digits of the file name here. So 860, 1860, 2860, 3860, 3978. So all the 860s is flight line number 1, all the 978s are flight line number 2, and all the 099s are flight line number 3. So all the ones after that we will remove for now. Now I will go to my settings and apply a roll offset to start. So we'll go guess a direction, either positive or negative, and guess a value. So we'll start with minus 0.5. Click through and start. While I'm waiting, I can go back to my multi-ortho and clear out the files that I'm not going to look at right now. So the last 3 flight lines. We said 860s, 978s, and 099s. So I'll get rid of these ones for now. Okay, once that hits 100, let's go back to our multi-ortho. We adjusted our files that we want. Our wavelength is still set to RGB. And now we can do ortho, but with a new name. So multi-OR roll minus 0.5. Okay, now we can open it up, select and open, and now review. So we adjusted in the side-to-side direction, and it looks like, actually this guy looks like it's pretty well lined up compared to before, but this guy is still off or further off. It's hard to tell. So let's look at them side by side. And again, we're looking at this compared to this, and since they cannot line up with a roll correction, because if I adjust the roll anymore, this guy could get better, but this guy would get worse. That tells me it's an EFL offset. And so I'm going to now go back to the drawing board and adjust my effective focal length. So let's try 12.5. Go batch and start. Okay, now that that has finished, we will again create the multi-ortho with a new name. EFL 12P5, roll minus 0P5. A bigger EFL makes the image narrower, and a smaller EFL makes the image wider. Open it up and review. Okay, so clearly this guy looks off and this guy looks off, but they look much closer in terms of equally being off. I'd say that this one's maybe a little bit wider than this one. So I think the EFL is close but not exact. So for the sake of moving forward a little bit quicker, let's go and check what the value should be. So we think that the correct answer is 12.6 for the EFL and a roll offset of minus 0.1. So let's go back and enter those. And these are the values that you would have traditionally been starting with. You wouldn't start with the zeros, you'd start with the values that we came up with for you. And so you would have a much less of an iterative process. Okay, so let's run this for the 12.6 and the minus 0.1, and then let's go and look at the yaw and pitch from there. All right, now that that has finished, we will go back to our multi-ortho, change our name, and go ahead, open it up. And now our line here and our line here are much closer. We might be able to do a slight correction to fix that after, but we're close enough where we're going to move on to the pitch and yaw, and we'll see if this looks the same or better or worse after we make those corrections. So we'll start with pitch, and we'll adjust trying to get this to line up and then check and see if that lines up or not. So again, we will choose a direction, positive or negative. We went negative on the last one, so we'll go positive on this one, and I'll just start with 1/2 degree. And batch, start. Okay, that's finished. So now let's review, adjust our name, pitch 0.5. Okay, so that looks much better. If we're looking at the two overlap regions, this area looks pretty good, especially for roll and pitch. But over here, I'm still seeing a little bit of a double image. So that tells me that we need to adjust our yaw. So I'm going to go back. And we'll try another 1/2 degree of yaw. Okay. Add in our name, yaw 0.5. Create cube. Okay, so now I'm seeing an offset over here and an offset over here, but the offset here looks bigger than there, so I still don't have the correct yaw value. But we're getting closer, so for the sake of time, let's go back and see what our values should have been. So it looks like I went the wrong direction for yaw, which makes sense from what I just saw, so I should do negative 0.45, and for pitch I should change it to 0.55. So let's do that and see how that looks. So pitch 0.55 and yaw minus 0.45. Change our final name. Minus 0.45 and pitch was 0.55 and create. And now for this is we expect a much cleaner image. There may still be some slight artifacts. You can expect that from flight to flight, location to location, or altitude to altitude, you may have some slight adjustments needed to these values, but they'll be much more localized small adjustments. So instead of doing half a degree adjustments like we were doing here, you might do a tenth of a degree or something like that to get things to line up as you expect. And now that looks much more like I expect it to. If we zoom in over here, maybe a small little bit of adjustment we could make there for some of these values, but overall I would say that looks pretty darn good to me. You can kind of go overboard in adjusting these forever, but basically you should get it to a point where it looks acceptable to you and then move on. And to me, I would say this looks within the realm of what I would expect. And so if I'm happy with this, the next and kind of final step would be to load in all of the files and apply it to the full flight. Again, we're going to ignore the first and the last cube because those were over the tarp, which was far away from our flight area. Sort by date modified and select all the RDRF files, except for the last one. And since we already generated those IGM files previously, I can load them in while those are being overwritten. So let's clear those all out and then select all the IGM files. Excluding that final one, which I remember to be this 19549. Again, we're just going to do this in the RGB for now. Looks like we have all of our 6 flight lines loaded in, and now we will wait for the orthorectification batch to finish before applying that to our final multi-ortho. Okay, and now that that is finished, keep our same values because those didn't change, but we can say 6 flight lines or some things like that. Okay, now that that's finished, we will open it up. And look at our full image, and looks pretty good to me. At this point, you could do some last minute final critiquing. If I zoom in, maybe there's a little bit there. Maybe a little bit there. So maybe my EFL roll could be slightly improved. But at this point, I'm going to call this acceptable and completed. And so now I have a multi-ortho mosaic of my entire flight, which was 6 flight lines in RGB. The next step would be trying to generate a full spectrum mosaic of the whole image, which is in general not recommended because that will be a very large file to generate, which you need a lot of disk space and a lot of RAM. And so instead, I might make full spectrum mosaics of individual flight lines or of 2 to 3 flight lines at a time, or generate a false color classification using our classification tool, and then making a mosaic of the false color spectrum, or something like that, which we will cover that in a subsequent video. And I think that is it for today. Thank you for watching. Hopefully this was beneficial.